Hello and welcome to the video on parallelograms. By the end of this video, you should be able to describe what a parallelogram is and name the properties of parallelograms. Let's start with the definition of a parallelogram. A parallelogram is a quadrilateral with both pairs of opposite sides parallel to each other. If both pairs of opposite sides are parallel, that means that side AB is parallel to side DC. And it also means that side length AD is parallel to side BC. So by definition, a parallelogram is a quadrilateral. Now remember that name means a four-sided figure with both pairs of opposite sides parallel. There are a bunch of theorems that we're going to learn about parallelograms, and these are just all properties of parallelograms that are true for every single parallelogram. The first one, if a quadrilateral is a parallelogram, then we know that its opposite sides are congruent to each other. So not only are opposite sides parallel, they are also congruent, meaning AB is congruent to DC and AD is congruent to BC. Now again, those are true for any parallelogram, not just the ones I have drawn here. A few other theorems. Not only are its opposite sides parallel and its opposite sides congruent, but the opposite angles in a parallelogram are also congruent to each other. This means that angle A is going to be congruent to angle C, and angle B is going to be congruent to angle D. Later on in this video, we will go through a proof to actually show why that's true. Yet another theorem, not only are opposite angles congruent to each other, but consecutive angles are going to be supplementary. So in this case, there's a bunch of different sets of supplementary angles. Angle A and angle B would have to add up to 180 degrees, as would angle B plus angle C, as well as angle C plus angle D and angle D plus angle A. The reason why this happens is because of our parallel lines. Remember, opposite sides of a parallelogram have to be parallel to each other, so line AB is parallel to line DC. Well, if I then have a transversal going through, remember that in this case, angle B and angle C here would then be consecutive interior angles. And we had a theorem way back towards the beginning of the year that said when those lines are parallel to each other, those consecutive interior angles have to be supplementary. Hence, all consecutive angles in a parallelogram are supplements. Those two ideas together lead us towards this next idea, and that's if a parallelogram has one right angle, then it has four right angles. And that should make sense here. If we look at our picture, if I know one of these angles, let's say angle A is 90 degrees, well, because opposite angles are congruent, angle C would have to be. And because consecutive interior angles have to add up to 180, well, angle B would have to be 90 as well. A few other theorems. If a quadrilateral is a parallelogram, then I know that its diagonals bisect each other. So in this case, if I draw both diagonals in here, I connect A and C and I connect B and D, I create a new point of intersection there. I'm going to call that point E. What this theorem says is that E is really the midpoint of both of those segments, meaning that the length from A to E is congruent to the length of E to C, because BD cut AC in half. And it works on the other diagonal as well. Because AC is bisecting BD, then DE is going to have to be congruent to BE. Again, it doesn't say that all four are the same size, but there's the two sets of congruent segments there. The diagonals have cut each other in half. And one last theorem for us here. If a quadrilateral is a parallelogram, then each of its diagonals will separate the parallelogram into two congruent triangles. Now I'm going to show this example with just one of the two diagonals, but it would work with the other one as well. If I draw in diagonal AC, I've basically created two congruent triangles here, and it'd be very easy to prove that using our previous theorems, because we just said earlier here, if this is a parallelogram, then its opposite sides are congruent. I know AB and DC would be congruent, and AD and BC are congruent to each other. I also know its opposite angles are congruent, so angle B and angle D would be congruent to each other. So by side angle side, I could prove pretty quickly here that these two triangles are indeed congruent. It would have worked the same way with the other diagonal. So let's try a few examples here. Example number one, we know that this thing is a parallelogram, And we want to figure out what WY, the measure of angle KLM, the measure of angle JLK, and the measure of angle JKL is. Well, let's start by figuring out what W is. If I look at my picture, I see a few things with W's in them. The length from M to N here is 2W plus 3, and the length from N to K is 3W minus 8. Well, we just had a theorem earlier that said if we have a parallelogram, the diagonals bisect each other, so I know that those two lengths have to be congruent. I can set the 2W plus 3 equal to the 3W minus 8, and then solve for W. I can do that by subtracting my 2W. When I do that, I get 3 is equal to W minus 8. Then I'm going to add my 8 to both sides to get 11 is equal to W, or W is 11. I can quickly make sure I got that right by plugging it back in. 2 W's would be 22, plus 3 would be 25, and 3 W's would be 33, minus 8 would be another 25. So we know they did turn out to be the same size. All right, now that we have W, we can move on and try to figure out Y next. If we look at Y, well, the only thing I see with a Y in it is the length JM here, that's 5Y. Well, we had a theorem that said opposite sides of a parallelogram are congruent to each other. So the 5Y has to equal the side across. So JM is congruent to KL, makes my 5Y equal to the 12. So when I divide by 5, I get Y is 2 4/10. Now we have some angles to find. The measure angle KLM. If I look for that, KLM is really this entire angle here, K to L, all the way over to M. Well, another theorem. If you remember back, opposite angles are congruent on a parallelogram. So I know that that angle is congruent to KJM, the one up here. So when I add the 33 and the 75 together, I wind up getting 108. So if angle KJM is 108, angle KLM is 108 as well. JLK is that angle right there. Well, I know that that angle is 75 degrees. How's that 75 degrees, you say? Well, remember opposite sides are parallel to each other. So if I have two lines that are parallel, there's my transversal. These two angles right here are alternate interior angles, which makes angle MJL and angle JLK congruent to each other. This does need to be 75 here as well. And the last one, what is the measure of angle JKL? Well, angle JKL is the angle over here. Now remember we had a theorem that said consecutive angles are supplementary. Earlier we said that angle MJK is 108 degrees. Well, if that's the case, its supplement, the angle over here, would be 72. All right, one more example here. Let's actually try a proof. Given that quadrilateral EFGH is a parallelogram, we want to prove that the opposite angles here are indeed congruent to each other. Now, to prove that opposite angles are congruent, I can't use the theorem that says if something's a parallelogram, opposite angles are congruent. We're trying to prove that theorem, which means I have to use some other theorems to do that. Well, like we would with any proof, we're going to start by writing out our given. We were given that EFGH is a parallelogram. From there, what can I say? Well, we know by the definition of a parallelogram that when something's a parallelogram, its opposite sides are parallel to each other. So I can say that EF is parallel to HG and EH is parallel to FG. Now that I know that those are parallel, I can use my rules with parallel lines and transversals. Angles F and G are consecutive interior angles, and consecutive interior angles have to add up to 180. I also know that since line EH and FG are parallel to each other, that angles H and G are also supplementary. Therefore, they have to also add up to 180. Well, now I can do a little bit of substitution here. What am I going to substitute? Well, I'm going to substitute some of these angles in for each other. I know that angle F plus angle G add up to 180. I also know that angle H and angle G also add up to 180. Well, if they both add up to 180, I can replace one with the other here, because if they're both equal to 180, they're equal to each other. Now that I know that the sum of those two angles are equal to each other, I notice here that there's an angle G on both sides of my equation. I can quickly subtract off that angle G to get angle F is equal to angle H. And after using the subtraction property of equality, I technically need to do one more thing here, because I'm really trying to prove that they were congruent to each other. I have to write one more step here saying angle F is indeed congruent to angle H. Because the measures of two angles are equal to each other, then they are congruent, because that's what congruent means. And that brings us to the end of the video on parallelograms. I hope you have a wonderful day.